All right, guys. I was thinking about starting with these warm-up questions on the bottom of 13. Would that be okay? Just this question number 9 real quick. We have a retake on angular linear velocity on Friday's summatives, so it seemed like a good thing to talk about. Let's see. It says Maury pulls a cord on his lawnmower to start it. In order for the engine to start, the pulley must turn 150 revolutions per minute. 150 revolutions per minute. The pulley has a radius of 0.24 feet. How many radians per second must the pulley turn in order to start? Well, that's kind of a gift question because by giving you the label, not just asking for the linear or angular velocity, I'm kind of reminding you that it has to be changed into what? So 1 revolution is how many radians? What else? Though this question says it has to be radians per seconds, so we need to get rid of minutes. And 1 minute is 60 seconds. So now minutes cancel, revolutions cancel. On the top, we have 150 times 2 pi. And on the bottom, we have 60. That actually divides out to be 5 pi, right? Or some equivalent decimal. Anybody have that? Thank you. All right, how fast must Maury pull the cord to start the lawnmower in feet per second? Ideas? Yes. Okay, I'm going to use the 5 pi just because it's exact. You could definitely use the 15.7. I don't care. Radians per second. And to get the linear velocity, we need the angular velocity times the radius. So the radius was 0.24 feet or 0.24 feet. So that's feet per second. That's it, right? So if we multiply all that and get a decimal, 5 pi times 0.24. Feet per second. Is that close enough? Somebody agree with that? Okay. Do I need to review an arc? Remember, arc length is this formula, and area of a sector is this formula. Okay, but what's the big deal about all those formulas? Yeah, it has to be in radians. So if they give you an angle in radians, you're golden. If they don't, you got to change it to radians before you use any of those formulas. Okay, any other questions about that stuff? Right, what about homework questions or questions on either? I mean, you're supposed to start, yes. 11. Okay, I don't think I have 11 open. Give me 1 second. Anybody have a question on 14 or not? Did anybody start 14? That was what we started on Friday, and we can do a couple more examples if we need to. I don't know how far we got on. Well, 14 is your assignment. We were doing 13 as notes. Okay, worksheet 11 is this, yes? The CUDA one? The homework one? Okay, which problem did you want me to do? Okay. What's going on here? Is this right, or does yours have a negative somewhere? Some of the questions I changed. That's right, okay. So the amplitude is, which is disgustingly tiny on this little graph paper. B is 4, so the period is what? Yeah, 2 pi over 4, which would be pi over 2. Are you all right with where that came from, Kelsey? Okay. Yes, so it's supposed to finish the whole cycle by pi over 2. It's a cosine graph, so it should start at its maximum. What is the max and min for this question, guys? Yeah, there's no vertical shift, so it's 1/2. It would start at 1/2 and finish the whole thing by pi over 2. So at pi over 4, it should be where? At the minimum, yeah, which was negative 1/2. So there's a couple periods of it, but let's worry about the ordered pairs. So if you and I were actually graphing this without the stupid graph paper, we would have said it needs to finish by pi over 2. So if we take the period and divide it by 4 to get the quarter points, we'd have pi over 2. And dividing by 4 means multiplying by 1/4. So we'd have pi over 8. So this would be 1 pi over 8. This would be 2 pi over 8 or pi over 4. And that would be down at negative 1/2. This one was at 0, 1/2. Kelsey, can you tell me the other 2 points? Good job. And that one's back at 0, right? Good job. And I think I said this a couple times already, but on the quiz, I don't give you graph paper because it's just easier not, in my opinion. I hate trying to fit to some predetermined graph paper. Questions? More questions on homework? Any of the homework? Do I have it right? Okay. Okay. So amplitude, guys? Okay, but the amplitude is just the 3. The shape is going to be, okay, but it's a sine graph, so. Okay, so it starts at the midline, right? Well, here, I won't put it on there. Starts at the midline, and it goes down first, okay? Because it's a negative sine graph. All right, then we have a couple other things going on. What's this -1 doing? It is outside the parentheses, so yes. So that means the midline is at -1. And what's this crazy b value got going on here? What is multiplied by theta?
1/3.
I shouldn't have wrote b equals, but b is 1/3, and then it's multiplied by theta. And so the period is 2 pi divided by 1/3, or 2 pi times 3 over 1, which would be. So it's not going to finish a cycle till out here at 6 pi. How far above and below my midline is it going? So that would mean all the maximums are going to be at 2, and the minimums are going to be at -4. Did I get that right? All right, here's my try. I'm going to start here. Halfway there, it's going to be back there, and then it's going to finish here. So it's going to go down. All right, so the period divided by 4 will give us the quarter points. So 6 pi divided by 4 is the same as, so the first one should be at 3 pi over 2. Does that make sense? Because 3 over 2 is 1.5, right? Does that fit between 1 and 2 right there? And that was at -4. Can you go from there, Kelsey, or you need me to keep going? Okay. So if you add another 3 pi over 2, you'll have 6 pi over 2, which reduces to 3 pi. Add another 3 pi over 2, and you get 9 pi over 2. Everybody good? Did anybody start 14? No questions? Anybody questions on any of the bookwork? All right. Worksheet 13. How far did we get on Friday? So we all right, then I'm gonna move on to modeling if no one has a question on 14. Are you sure? No one has one question on 14? Yeah. I don't think one was assigned, was it? Okay, so let's just do one for a warm-up. Good question though, but this is worksheet 14. I think the directions say to do cosine, don't they? So we need a maximum to a maximum, and so I would go with these 2 points right here because they're labeled down here, even though this labeling is totally wonky and crazy. So this ordered pair is apparently 315, and this ordered pair is 1915. You're going to have a lot of this today when we do modeling, where you're really not sure what all's going on, but you have a couple of ordered pairs. Okay? The amplitude, by definition, is max minus min divided by 2. The vertical shift is max plus min divided by 2 because it's the halfway. Okay, the period is the length that it takes to do one, and the phase shift is where we start counting. So if we're gonna, somebody tell me something about this. Keaton, can you tell me anything? Period, amplitude, vertical shift, phase shift. Okay. How long did it take to get from 315 to 1915? What's the length? Yes, 16. So that's actually the period. That's not what's going to go in the equation, though. Can anybody tell me what's going to go into the equation? That makes B become what? Yeah, 2 pi over 16, which will reduce to pi over 8. All right, the minimums are occurring at 3 here. And the maximum are occurring at 15. So what's exactly in the middle of those? Guys, if you add and divide by 2, you get what?
9.
Exactly in the middle. So 15 plus 3 divided by 2 is 18, divided by 2 is 9. So this midline is y equals 9. 9. Where does that go? Yep. Okay. Now, once we know that, then the amplitude is just how far above that and below that did it go. Yeah, that's the 6. Okay. If this is 9, it went 6 above and 6 below, and make sure those are the same. You could have done 15 minus 3 is 12 divided by 2. And you could have found either one first. All right, phase shift, guys. Yeah, if we're going to start by talking about this piece of the graph, we're going to say it shifted to the right 3. All right, so our equation is y equals a cosine b x minus c plus d. or plus or minus c. We'll figure it out as we go. But what are we going to do? Y equals, what's our amplitude? Did we decide it was a positive cosine? No, flipping it upside down, right? And then cosine. Okay, but b goes in front of the x. The b is pi over 8, remember? And then be careful, if it's to the right 3, it's what? Minus 3. And then up 9 on the back. Now, what mode are we in, guys? Yeah, we do all our graphing in radians. I just want to show you so that you've checked one once, because we're going to do this today. Could someone read me that equation that we just wrote? Was it 6 sine, cosine, and then it was pi over 8 x minus 3 plus 9? Okay, I need to make sure that I'm in radian mode, and then I need to set a window that's similar to theirs. How far did it go to the right? I'm just making something up here. All right. All right. No, because I wanted my window to match what they had. And they're like negative something out to 20. They don't actually have negative y, but yeah, I did this wrong. 1. Thanks. Okay. I was like, So if we do trace over to 3, we're at 15. Does that seem okay? If we go to 19, is that where we thought it ended? It's back at 15? Okay. So do you see how easy these are to check if you put them in? All right. If no one else has a homework question, I'm going to go ahead and start working on 15. All right. Nobody? All right, guys. This lesson looks all fancy. I'll be real honest and tell you I was evaluated one year, and so I made really fancy slides here. But it is a really important Common Core standard that you can build a function that models two relationships, including trig functions, okay? When we say sinusoidal functions, I just need you to know that sinusoidal doesn't necessarily mean you have to use sine. You can use cosine, okay? We've talked about that before, but here's my definition. A function that is like a sine curve. It can be produced by transformations of sine or cosine graphs. All right, there are so many things in real life that are periodic, okay? This was a bunch of tsunami stuff. Do you see how that's periodic? This graph down here, yeah, I don't know what that is. It's not labeled. This is hours of daylight. I found a cool, I wish we had an extra day in our schedule to do an experiment. I found a cool thing that uses sunlight, but all right, I can just about guarantee there's going to be a Ferris wheel question on the quiz. So, I think I even have here. Nope, doesn't work. I don't know if I can do that. Yeah, all right, forget it. I had a cool Ferris wheel, but it's a Flash app that it's not supported anymore. But I mean, I could Google what a Ferris wheel looks like. Everybody, you get on here, the bottom, and you get higher and higher and higher, and then you get lower and lower and lower, okay? So as a function of time, your height goes up and down. Does everyone understand that? It says, as Rashad rides a Ferris wheel, his distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, Rashad's seat is at the position shown here. He's randomly some amount off the ground when time starts. We don't know. Let T be the number of seconds that have elapsed since the Ferris wheel started. Rashad determines that it takes him 3 seconds to reach the top. So, into our story, 3 seconds, he is at the maximum height. Does everyone understand what that's saying? He didn't start at the minimum, he didn't start in the middle, so we don't have any really idea where this was. But we know 3 seconds in, he hit the maximum, which is 43 feet above the ground, okay? So 43 feet above the ground. So we have an ordered pair of 343. He also determines he is back in his original position after 8 seconds. Well, you would think that's not helpful because we don't know where his original position was. But, oh my, ugh, that was horrible, Hofbauer. I don't know what that is you even drew. So what they're trying to say here is that one revolution took 8 seconds. So if he started here, wherever here was, and he went all the way around, he's back there at 8. So if he was up here at 3 seconds into the story, and all the way around takes 8, he's back up there at what? Yeah, it's telling you one revolution takes 8 seconds. That means the period is 8 seconds. So he's back up here 8 seconds later, which would put him 11 seconds into the story when he hits the top again. All right, the diameter of the Ferris wheel is 40 feet. Now we need to be real careful with that information. Is that the amplitude? Okay, if all the way across is 40 feet, and the maximum he ever went was 43, how far was he at his lowest above the ground? 3, okay. So if the lowest he was 3 and the highest he was is 43, what are we going to do to find the amplitude or the midline, either one? Okay, if we add and divide by 2, we get 46 divided by 2 is 23. What is that? It is the midline. Because how far above and below that is he going? 20 above that and 20 below that. So what is that 20? Yes. So go back over here and look at the picture and think about this for a minute. He got on, he was 3 feet above the ground. He got higher, 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 all the way up to 43. Okay. Going back around. So this is 20 and this is 20. That's the radius, and the radius tells us the amplitude. Does that make a little bit of sense? Okay. So I'm going to make some notes over here. We know the amplitude is 20. We know the vertical shift is what, guys? Where the midline was 23. What else do we already know? The period was 8 seconds. So that means into our equation doesn't go in 8, but a what? A 2 pi over 8, which would become pi over 4. And honestly, I don't care if you want to just put 2 pi over 8. I don't care. We know one more thing, though. If we try to sketch this, and this is what too many students do, they try to sketch this and somehow work from the beginning without a phase shift. If you just would start here, I don't even know what he was doing back here. But the bottom line is our story really starts at 3 seconds in, right? So I'm going to use a phase shift of 3 to the right because it says that's when he hits his maximum, so that's when I can identify that it was a cosine at that point. All right, let's answer some questions here. What is the lowest you go as this Ferris wheel turns? 3 feet. And why is it greater than 0? Yeah, you're not going underground. Your feet don't hit the ground when you go around, right? Write the equation. Okay, anybody think they got it? What do you have? Okay, I have h of t, but that's fine. I'm going to use t, but I'm not picky. If you do x, I would not count it wrong. Okay. What do you think? Anybody think he's wrong? Now, he wasn't listing off parentheses, but you won't get it right unless you put those parentheses, okay? So now the rest of the question is about putting numbers into that. So I want you to grab your calculator and type this equation in. Was it 20 cosine pi over 4 x minus 3? Make sure you close both of those parentheses and then up 23. Did I remember it right? Okay. What mode do we have to be in? Radian. Now, what window would work for our story? Okay, so x is going across. I didn't read the rest of the question. I'm just going to leave it maybe at 20. Do they ask us to go out? Can anybody tell me what it says about time on the next part of the question? Does it ask us to go out past 20 seconds? Okay. Okay. And then up and down, you could leave it 0 or something a little bit negative, but it goes up to what? 43, so we could put 50 or something. All right, so how could we test that this made sense? Yeah, trace 3, enter, 343 is working. We decided 11 should be the next time it was up at the top, right? 1143 is working. Okay. Now we're going to answer the questions that were asked. Predict your height above the ground at t equals 6, t equals 4 1/3, t equals 9, and t equals 0. You can do that from the table or from tracing. The 4 1/3 would probably be easier from tracing. Oh, great. I shoved it off the bottom here. So at 6, I have 8.9. I'm going to type 4 plus 1 divided by 3 would give me 4 1/3 exactly. But I got 33 feet for that. Did anybody else get that? We put in 4 1/3. You put in 4.33. You're pretty close to 33. 9. I have 23. And then it asked about 0, didn't it? So when it actually started the ride, in other words, where they didn't put more people on it, yeah, he was about 8.8 or 9 feet in the up. Everybody good? I'm going to assume you filled those in. All right, so that was a Ferris wheel question. Now we're going to try a spring question. Do you remember the video we watched They had the harmonica. They showed a spring on that one, right? Going up and down. Or did they only show a piston? I can't remember. Sorry. A weight attached to the end of a long spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. You start a stopwatch and it reads 0.3 seconds the first time the weight reaches a height of 60 centimeters above the floor. The next low point, 40 centimeters above the floor, occurs at 1.8 seconds. Okay. So at 0.3, it was where? 0.3 was 60 centimeters above the floor. I'm thinking that's the max, don't you think? And then the low point is 40, and that occurs at 1.8, which would be all the way out here. Okay, if we went from a max to a min, is that a period? No, okay. You will not show a whole period on this sketch. Now, we could make it show a whole period. Ugh, that was horrible. If we were to continue back up over here somewhere, that was even worse, Hofbauer. Somewhere out here, it would finish a period. Okay. How long did it take to do this half a period, guys? From 0.3 to 1.8 is how far? 1.8 minus 0.3 is 1.5. Is the period 1.5 then? It's 3 because it's twice that long. So that's half a period. So if we added another 1.5, so where does this occur? If the whole period is 3, yeah, it's hitting a max of 60 at the end of a period. But how long does it take? Or what is the time at the end? This is a distance of 3 from beginning to end, so it would be at 3.3, right? Because it was shifted to the right 0.3. Really what you need to know is that the period is 3. Because 1.5 seconds took half a period. Anybody may explain that better? Okay, so I went max to min, and it's going to bounce back up to max, and it's going to take the same amount of time it took to get down to get back up. All right, what else do we know? How do you, okay, the minimum is at 40, right? And that occurred at 1.8. So where's the midline? That shouldn't be too hard. What's halfway between 60 and 40? The midline is at 50. And what does that midline tell us? That's where students get confused. Is it the amplitude or is it the vertical shift? It's not. It could, the number could be the same, but it's not. If this is 50, is that the amplitude or the vertical shift? Yes. The vertical shift is 50. It will help us find an amplitude of what? Yes. All right, what are we going to call this graph? The cosine. And is it a positive or negative cosine? Yeah, we're going to say it was doing this, and then this, then back up somewhere down here. Okay. We have an amplitude of 10. Whoops, that's an 11, Hofbauer. And then we're writing cosine. Now, we need to figure out what B is. How long was the period? Yes, it was half a period was 1.5, so we decided the period took 3. So the B value is 2 pi divided by 3, right? Nothing pretty there. Phase shift? Yeah, right 0.3, right? So x minus 0.3. And the vertical shift was the plus 50 at the end. All right, let's try graphing this. Tan cosine 2 pi over 3 x minus 0.3 and plus 50. All right, so my window needs to change. Definitely don't need to go out 20 because our story only got to like 1.5 seconds, right? So maybe I'll go out to 5. And what was it maxing at? So we need to go a little bit higher here. All right, so I'm going to do trace 0.3 to see. Yeah, it's at 60. And then at 1.5, whoa, 1.8 it told us it hit a minimum. Is that right, guys? Yeah, 1.8 it was at 40. Okay, so it seems like we're doing all right. Predict the distance from the floor when the stopwatch reads 17.2. Okay, 2 ways to do that. Anybody tell me? Okay, I can trace 17.2 isn't going to work on mine. Do you remember why it didn't work? It's not in my window, yeah. So I could look at the table, but I would have to probably put it on Ask Auto. Because if I want 17.2, right? So now I can put in a 17.2. And I got 43.3. Did anyone else get that? The other option is just to make my window go out past 17.2. And then it'll let me do a trace. But it's not going to let me trace out to 17.2 unless it's actually in the window. 43.3. You could also just go to the home screen and type it in, the 17.2, but it's kind of miserable because you got to type the whole darn equation, 10 cosine 2 pi over 3, parentheses, 17.2 minus 0.3, parentheses, plus 50. Be kind of miserable. So what did we get? 43.3. And what was the distance from the floor when you actually started your stopwatch? How would we find that? Yep, if we just did a trace 0, was 58.1 about feet off the ground. Was it feet, meters, centimeters? Thanks, somebody fix me. All right, how you feeling? These aren't making you cry yet? Let's see how far we can get on this one. A tsunami, commonly called a tidal wave because of its effect is like a rapid change in tide, is a fast-moving ocean wave caused by an underground earthquake. The water first goes down from its normal height and then rises an equal distance above its normal level, and finally returns to its normal level. The period is about 15 minutes. Okay, that seems important. Suppose that a tsunami with an amplitude of 10, oh, they gave us the amplitude, nice, approaches the pier at Honolulu where the normal depth of the water is 9. Assume the depth will vary sinusoidally with time. Okay. So normally the water is sitting at 9. So I guess we'll go with 0, 9. And then what happens? What does it say happens first? Goes down. So what are we going to do? How far down? Yeah, it says an amplitude of 10, so it's going to go down, and then it's going to come back to where it was, and then what's it going to do? And then the actual tidal wave or the tsunami comes in, right? And it goes up another how much? 10, so that would be 19. And then back to where it was. Okay, who can tell me something about this graph? Midline? Yep. Amplitude? They told us amplitude was 10. What do we want to call this maybe? So we don't have to do a, yeah, we could call it a sine. What kind of a sine if it went down first? Yeah, if we do a negative, what's the amplitude again? Negative 10 sine. 2 pi over period. What's our period? They told us. 15 minutes. Do we need a phase shift if we do a negative sign? No. And our vertical shift you said was midline at 9. So now you could just plug in 2, 4, and 12, and for that one you could actually use the table because they're nice round numbers. Okay. It does ask some weird questions down here about wavelength, but we can skip that for today. What would it look like? What is this? How do you have a depth of -1? If you were standing on the pier and it's normally the water underneath the pier is 9 feet, what would it look like when it went to a depth of -1? Yeah, if the water pulled back so that it was -1, there really isn't going to be a -1, but you're going to see the floor of the ocean, right? Or the beach. You're going to see more sand than you usually do because the water is pulling back. And then when it comes flying at you, then it's going to be twice as tall. Be 18 feet. So it's going to be 9 feet over where it usually is. All right. Any questions? So you are to start working on worksheet 16 and 17 tonight. I did not assign them all. Is this right, guys? Anybody have their homework check out? I only skipped 9. Hey, I said you could skip 8 and 6. Okay. I knew I cut it down a little bit. Oops. All right, so this is the assignment tonight. Hopefully I will see you tomorrow. Hopefully the weather cooperates.